Hello and welcome to part 3 of our tutorial on i2 iBase Designer version 10. My name is Jean-Jérôme and I'm part of the i2 support team. In this video, we'll explore the overall process of designing the structure of a new iBase database from scratch. By the end of this tutorial, you will understand the concept of entity types and link types in order to create a well-structured database tailored to your needs. Understanding the basics of iBase structure. When you first launch iBase Designer, the database is completely empty. There are no entity types and no link types. You have the option to use an iBase template that already contains entity types and link types, but in most cases, you will need to build your database from scratch. In iBase, the world is modeled using entities and links. Entities represent objects or individuals, such as person, a vehicle, a location, or a phone. Links define the relations between these entities, such as a person knows or works with another person, or a person owns a car, a telephone calls another telephone, or a person is being employed by a company. Defining entity types. The first step in structuring your database is identifying the entity types you will need. Most iBase databases will include at least the following common types: person, addresses, organizations, phones, and documents. But most of the time, those entity types will not be enough. So you must ask those key questions. What data will I be handling? And what kind of real-life objects do I need to represent? For example, if in your analysis you're dealing with horse racing data, you will likely need an entity type for horses because your analysis will revolve around them. However, in your dataset, you might also have jockeys, veterinarian, male or female, horse owners, horse race gambler, and track officials. You must not create a distinct entity type for each of these type of person. What you must do is you must create just one entity type person, and you will create a field which defines each person's role. This prevents duplication and allows for flexibility, as a jockey can later become a horse owner. Similarly, if you work with multiple animal types, for example horses, cows, pigs, it may be more efficient to create a general animal entity type rather than separate entities for each species. Most animals share common attributes such as a unique tag or a unique identifier, date of birth, and place of birth. After you've defined the entity types, you can start thinking of the link types. So what I will do is that I will draw the different possible links. For example, a person might live at an address, an organization might have an address as a location, a person can use a phone, and the horse can be located at an address, and I will change the color. You might have a document which talks about horse, which talks about organization, which talks about person, which talk about addresses. I forgot the fact that an organization can have a phone. And so, of course, there is no point of creating a connection or link between a phone and a horse. What you can do is create a link between an organization and a horse, because sometimes companies can own horses or parts of horses. And I forgot also to create a link between a person and a horse. You can also have a link between a person and a person. For example, a person knows another person, so I will draw this as a loop. You can also have an organization which is linked to a different organization, and a document which talks about or which refers to another document. So those are the very crude drawings. What we will do next is we will draw the same thing in an ISO book. What is important is you must find the right balance in link types. A common mistake is to create either too few or too many link types. If you have only one generic link type that connects everything to everything, the data will lack structure and meaningful analysis. On the opposite, if you have too many specific links, for example, if a link between a person and person, you have one link type for father, one link type for brother, one link type for cousin, one link type for uncle, and so on, it becomes difficult to manage and analyze the data effectively. as a general rule, should aim for a maximum of 3 distinct link types between any 2 entity types. However, this is not a strict limit. Exceptions may apply based on your datasets. So I'll go back to the drawing I did with the entities and the links, but the links I did were manually drawn. If only we had a software which would allow us to create links between entities. But hey, wait, that's an Aesop book. So I've launched an Aesop book, and what I will do is I will recreate on the chart this drawing. So I do have the person, I do have the telephone, I have the document, I have the organization, and I do have the place, the house. Okay, so I change name, address, this is just phone, this is person, and for the horse, I don't have it in the common palette, so I need to go to the animals palette. In here, I do have the horse. Okay, so if I go back to the drawing, I have this is correct. So now I will create the links. So I go back to common here. So let's zoom a little. Okay, and I will create the links. So there is a link which is cited in from the document. So I will create a link between document and horse, and this one is cited id. And as I want to create several links, what I will do is that I will double click on link, and it will allow me to automatically create more links. So again, this one here, F2 to change the label. In, again, this one, in, then this one would be owner. Okay, I can change the place because you see this place, the two labels are the same place. I click here on link, I press Alt, and I can move. This one is so the same. This one, okay. Then I can click on. I can create a link between person and address. So this one will be location. So this one will be also location. Okay, and the horse and location also. Location, and just move this closer to address. Okay, now a link between person and organization. So there might be several links. So I will create the first link, which will be works for. And so owns. This one will be, for example, shares, or own shares, and also between the person and the horse, which will also be shares. Okay, for the link between the person and the phone, so currently it's just a generic link. So I will change the label to subscriber. So this one I will put it on next to the phone. And a person can also just use a phone, but might not be the person who owns the phone. He uses. Okay, so we might add more links after. What is important to keep in mind is the fact that the structure of the iBase database can be changed once it has been implemented. You must not hesitate to experience. Designing an iBase database structure is not an exact science. iBase allows you to easily change the database structure. It's also very easy to create a local iBase database in Access format, create some entity and link types, test this database by importing data, make your first analysis, and check if the structure is correct or it should be modified. Also, work with your colleagues, do some brainstorming sessions to discuss what would be the best database structure. Now that we've created the generic database structure, now we must look for the fields for each entity and link type. Each field is defined by a name, description, a type, whether the field is a text, a date, a number, a picture, and so on, display format, a default value, whether this field will be sent to the analysis book chart as a chart attribute, and is the field indexed, mandatory, discriminator, and characteristic. And for each field, we can also define the semantic type. And there are a special case of fields which are called the standard fields. Those fields will be added to every entity and link types automatically. To help you with designing the iBase database structure, we recommend you that you use definition sheets. We do provide definition sheets for entities and for links. So here is an example of the definition sheet for the entities. You see that you have the entity type name, the default icon, the semantic type, the entity description, which is some text to define what is the entity is for. Then you do have a table where it shows the link to other entity types, what entity type and what type of links. Then we do on the right, we do have a table where you can input all the fields definition for the entity type. So for each field, you would have the field name, the type, the checkbox whether it's indexed, mandatory, discriminator, characteristic, and a display format, attribute, default value, and semantic type. And then you do have the standard fields. And for the links, you do have the same thing. You have the link type name, the link color, the link description, what are the valid entity types for the ends. So for the entity type A, you have the list of entity types, and for the entity type B, you have the list of entity types, and you say which is valid. Then you also have the fields definition for the link type and the standard fields. This is the end of part 3 of the video on the iBase Designer tutorial. See you next video. Bye.